Okay, for number 5, the proof one.
Okay, number 5.
Is it possible to draw out? I tried to like.
This guy right here?
That one. Yeah. I tried to like draw out the triangle, and I don't think it was right.
Oh, that's good. It's possible. All right. Occasionally they make mistakes. So,
Okay.
all right.
The
Hold on.
kind of weird.
Yeah, no, that's okay. So I'm just going to write it out now. Now look what I would do right here, because they gave me what I'm trying to prove. Right. To me, QS, it overlaps. Do you agree?
Right. Yeah.
Right. So to get something to overlap, I'm not sure because they don't have it drawn. I'm just taking a stab at it. You see what I'm saying? And then if I have this, then this would be Q and this would be S. Right?
Oh, that's how it
And then I would put P here and R here. So now I have PQS and RQS. Does that make sense? And again, I wouldn't do that. All right, I'm not going to give you on the test make you figure out what the drawing is. You know what I mean? I didn't recognize that it wasn't drawn for you, although it is a good exercise. It's not a big deal. Yeah, now we're going to do a proof.
Oh, okay. I was just wondering, like on that one, I guess it does have angles, but if it doesn't have angles, then I don't know how to do the proof.
Yeah, we're gonna talk about it. All right, because this really is like I think the biggest chapter for proofs. All right, and again, I'm saying start out here. If you didn't try the proofs last night, you're way behind. All right, it doesn't matter if you're right or you're wrong. It's matter that you're giving it some thought, and then it builds. You get a little better every day. But if you don't try it every day, then you're not going to be good at it. And honestly, it's the rules. It's actually pretty easy. All right. The hard part is you have to remember all the possibilities, all the old parallels, and all those theorems you have to try to remember to put together to make a proof. All right. So here we go. It says angle P is congruent to angle R. So I'm going to mark P congruent to R. And then it says angle PSQ is congruent to RSQ. And then PQ is congruent to QR. And PS is congruent to RS. So all that is what? Given. Is everybody with me? So again, I kind of like our notability rules. Guys, try not to be lazy. All right? And what I mean by that is, you know, I'm agreeing with you that I don't like to write out the given. But as I tried to show some of you guys yesterday, all right, your statements and reasons, now with this little thing I figured out, the whole given, I can copy and come down here and paste, and now I have that as step 1. And you don't have to write it all out. All right, and you come down here and write given. What?
So, can I solve it?
Okay.
So QS equals SQ by the reflexive property?
QS is congruent to, now I would have just said QS.
Okay.
Right, but again, I don't really care, right? Because I think technically you're actually correct because of the way they want. No, actually I'm correct this time because let me show you why I'm correct. Because notice here, QS.
And QS.
There you go, right? Yesterday we did one where the order was switched. All right, so if you put it the correct way or incorrect way, I'm just telling you, I don't really care. That's not the detail I'm interested in. All right, there's technicalities. Some math teachers go crazy if you write QS is equal to QS or QS is equal to SQ according to the figure. All right, I don't really care. I just know that you know that means that's the what? Reflexive.
And then for the third angle theorem?
Yep, that's exactly correct. All right. So step number 3, we're going to say that
PQS is equal to RQS by the third angle theorem.
and then third angle theorem. Right? So PQS, 1, 2, 3, is equal to RQS, 1, 2, 3. All right? And then, hold on one second, Ryan, I'll get to that. All right, so the final step would be what?
Would be that PQS is equal to RQS.
Triangle PQS is congruent to triangle RQS. Now the reason, you remember?
Because,
Definition of congruent.
yeah.
All right, yes. Definition of congruent triangle. Remember that just you equal yourself. So PQ, so QS equals QS.
And can you switch that to QS?
We already had that conversation. All right. That conversation was this. I said I didn't care. But listen, I'm right this time. I wasn't right yesterday. Look at QS here. Do you see what I'm saying? QS is to QS. You understand what I'm saying? It's not QS is equal to SQ this time. Right? Because of the way it's written. Okay.
So I put that angle PQS was congruent to angle RQS by alternate interior.
Well, that would be.
Because I drew it as
Yeah, but
square cut in half.
but
Can you only do that if the figure is drawn?
well, you'd have to know that those lines are parallel.
Okay.
You with me?
Yeah.
And so this is yours is specific to a square then.
Oh, right, because this one we had
You with me?
made sure that they were
They're
parallel.
parallel.
Okay, yeah.
Right? So when you're drawing the figure on your own, you can't assume that what you're drawing, the lines are parallel or perpendicular or any of that. All right? Yes. That just means if two angles of a triangle are congruent to two angles of another triangle, then the third angle has to be congruent. That make sense? All right. So step number 4. I didn't write step number 4. Step number 4 would be this. Copy that. And then put definition of congruence. All right. If all the parts and all the angles are congruent, then the triangle is congruent. What?
Could you prove that PQ and SR are parallel?
No. Well, actually, yes, there you can. You can, but that's believe it or not in probably a month. All right. Yep. All right. Just remind me right before. All right. So, was there anything else you want to look at on this?
Yes.
What?
The first two, number 2.
Okay.
I just didn't get like the given.
All right. So listen to me on this now. I'm not going to write out the proof because it's easy, but I'm going to say what you should have written. Okay. So stay with me. Right off the bat, BD bisects angle ABC. So I look at ABC and I'm going to mark it. You agree with that? That's so you could say those angles are now congruent by definition of bisect. You good on that? This, it says, and it bisects ADC. Definition of bisect. Now I can say this angle is congruent to angle C. Third angle theorem. And then it says AB is congruent to CB. And AB, I'm sorry, AB, wait a minute.
Yeah.
It says AB is congruent to, CB, yes. And then,
How
They made a mistake on that. It should be DC, right?
That was my question. How is AB congruent?
Yeah, they honestly made a mistake. You understand what they're saying though, right? They just made a typo. The people who edit these don't know math. They just put what the person said, right? So in this case, let's make sure I'm correct. AB is congruent to CB. I agree with that. And then this should be AD is congruent to DC, right? So I'm just going to erase this. AD is congruent to DC. Is everybody?
Yeah.
Okay, CD. Yes. Not that it matters, as I was saying earlier. So these two things are equal now. And now we would just simply say BD is congruent to itself by the reflexive property. Right?
And you can just do that by the triangles are congruent.
Yes. Definition of congruence. Go. Good.
Okay. So why couldn't you just do from all the stuff that you collected that line ABD is congruent, angle ABD is congruent to angle CBD, and then they're just whatever the alternative interior here, and then do angle.
There's no parallels. Right? You have to be careful when you're talking about alternate interior or corresponding. Nothing there is parallel. Yes.
So since there's nothing parallel there, you can't do vertical angle.
Well, vertical angles don't have anything to do with parallel. But there really aren't any vertical angles there either.
Or not vertical angles, alternate.
There's no parallels. Nothing's parallel. No, I said bisect. You just said the angles. The two triangles are congruent.
By
Definition of congruent.
yeah, so it's not the same as saying they're congruent because all the angles are the same.
No. In order to say something is congruent right now, you have to say all angles and all sides. If all angles and all sides are congruent, then they are congruent. Because remember we said yesterday, you can have angle like a square. Just because the angles are all congruent doesn't mean all squares are congruent. The sides and the angles,
Oh, okay.
right? The sides and the angles.
The definition of congruence is sides and angles.
That's correct. If all the sides are congruent, all the angles are congruent. All right, let's move forward, guys. All right, so pull up 4-4. Pull up 4-4 real quick.
Is it the same thing like triangles?
Yeah, it's absolutely the same thing. Except today, all right, except for today, we don't have to prove all the sides and all the angles.
Yes.
Right? We just have to prove 3 parts. Or we just have to prove 3 parts. All right? And actually, there's 4 or 5 different ways to prove triangles are congruent. But, is everybody with me? Is everybody up?
Almost.
All right. All right, here we go. Look up if you're not there yet. Proving triangles are congruent. If I gave everybody in here 3 sides of a triangle, for example, 3 inches, 4 inches, 5 inches, and said, make a triangle. If all 3 sides are exactly the same length, we're all going to have what?
The same triangle.
We're all going to make the same exact triangle. Everybody hear me? So one way to prove triangles are congruent is by SSS, which just basically means what? Side, side, side. So if you say all 3 sides of a triangle are congruent to all 3 sides of another triangle, then those triangles must be what? They must be congruent. All right? Now, what do you think SAS stands for?
Side angle side.
That is correct. So now, what is side angle side? Let me demonstrate, because there's a lot of people who make mistakes. Here is a side. This is the angle. Then this is the side. If that's the same, and hopefully visually you could see it.
Oh yeah.
If the angle is the same and the two sides
Are the same.
are the same, there's only one triangle that can be made. There's only one triangle that can be made. This is called side angle side, right? So if you prove a side, the included angle and the side, that means no matter what, everybody's going to have the same exact triangle. All right? Very straightforward. And I tried to visualize it up there for you. If I gave you a specific angle, let me give you an example. If I said this was 20 degrees, this was 20 degrees, and this was 3, and this was 4, this was 3, and this was 4. If I said construct a side of 3 inches, make a 20-degree angle, and then construct a 3-inch side, everyone would draw what? Exactly the same. And if you draw that exactly the same, when I connect the endpoints here, that's going to make the what? That's going to make the same exact triangle. Now, again, to me, like I said, I thought that's kind of logical. All right, but for some, that's not. To me, that was easy. Side, 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 side angle, side. Those are two methods to prove triangles are congruent. Quick.
So there's not really a difference. Like, is the first triangle that you drew SSS?
The first triangle, if I wanted to do SSS, would have to be like this. If this is 3, 4, 5, 3, 4, 5, that's side,
so
side,
it's
side.
just switching one of the sides on the side angle side.
You're making it too complicated, man.
It has
Way
the
too
same
complicated.
side.
Listen to me. It's if you draw a side, an angle, and a side, exactly the same as this side, this angle, and this side, they're the same triangle.
Okay.
That's all there is to it. Don't make it any harder than that. All right? Tomorrow we're going to learn angle, angle, side, and angle, side, angle. All right? There's just different techniques of proving triangles are congruent. All right? So here we go. Now, again, here is what this is. Just a quick little review, just to make sure. This right here, stay with me, is angle, side, side. This is side, angle, side. For some reason, every year I have to explain that. I don't know what the explanation is. All right, you move from one to the other in a counterclockwise or clockwise. I could write this as angle, side, side, or side, side, angle. Over here, I can write this as side, angle, side. If I reverse it, it's the same thing. Those are not the same. Those are not the same.
So you can write it ASS or SSA like on the test. I won't.
No, it actually, I'll probably turn you in, all right, to the dean for writing obscene things on your paper if you do that. All right? No, ASS is, you cannot prove triangles are congruent by ASS. All right, and I'll demonstrate why. It's called the ambiguous case. When you take pre-calculus, you'll do a whole lesson on this, but I'll summarize it in a few seconds. All right, and I'll show you why you can't.
Could another way to prove triangles if a line bisects a triangle with the two?
We'll get to, I promise you, we got so many problems to do. All right, you'll see everything.
If YXZ had the angle on the bottom, could you?
There would not be, no, that's angle, side, side. All right, trust me, we'll go through all the demonstrations here. All right, we'll go through all the demonstrations. That is not the same. These triangles are not congruent.
Why for the bottom would you make it angle side side instead of like C to B and then B to A? So side.
Listen to what I'm telling you.
Oh, because
Start.
it's not marked.
You just gonna answer your own questions, or you asking me? Shh. Sometimes you think in your head and don't realize you're thinking out loud. You're asking me questions and you're answering your own questions. If you understand it, I'm just gonna go on. You got it or not?
Yeah, I got it now.
I thought so. Here we go. Over here, are those two triangles congruent? Yes, because it's side, angle, side. right? Now, remember this. For side angle side, listen to me. Side angle side. The angle is between the two sides. The angle is between the two sides. Does that make sense? All right. The angle is between the two sides. That's what that means. All right. So those triangles are congruent by side angle side. Over here, do we have parallel lines?
Yes.
We have parallel lines. So in this case, angle 1 is congruent to angle 2 because those are alternate interior angles.
Yeah.
So now those triangles are congruent by side angle side. That's where I'm saying you're going to use all the information from the last chapter, all right, to prove these triangles are congruent. All right? Now, again, here we go. Let's write a 2-column proof here. But in the interest of time, right, you're just going to pay attention. Look up here, please. Don't write the proof. Don't write the proof. We're going to say it together so you can see how simple it is. All right? Generally, the given, listen to me, generally the given, all right, should be written first. All right? And then you always mark the figure according to the given. All right? So right now, I have NP is congruent to PM. Now it says NP is perpendicular to PL. Therefore, those angles are what? Right angles. Right? Perpendicular lines, it said, by definition of perpendicular lines, form 4 right angles. Right? So now here's where I'm going to talk to you about how the proof should be going. All right? Does everybody agree they form 4 right angles?
Mm-hmm.
Right. So now we can say that PL is congruent to PL, right? By reflexive property, right? So now, here's the mistake kids make. Now they can say those triangles are congruent by side angle side, but that's false, right? The reason why we can't say is because we can't, although we said that NPL is a right angle and LPM is a right angle, there's just one extra step. All right? You have to write that NPL and LPM are right angles because that's the definition of what? Perpendicular. The only other step that you would need to say then is that NPL is congruent to LPM because all right angles are congruent. Is everybody with me on that? Or when you say something is perpendicular, you don't say that the angles are congruent. Is everybody hearing me? You say that the angles are what? Right angles. Which means that they are what? Congruent because all right angles are congruent. All right, so when you fill in a proof, kids just forget that step. All right, now personally, I think you should be able to say if there are 4 right angles, you should be able to say that all those angles are what? They're all, well, yes, but they are congruent is what I was trying to say. All right, if they're 90 degrees, then they are what? Congruent. But every proof has that extra step in there. So you have to write that in there. All right, if things are perpendicular, if lines are perpendicular, they form right angles. After you say they form right angles, you're going to have to say that the lines are what? Congruent, because all right angles are congruent. What?
Can you write that down? How would you write that down? Just write it.
I don't know what you mean.
Can you write it 2 complicated?
No, we're not doing that. All right, the reason why I'm not doing that is because I have a whole bunch of proofs to do. Right, and I'm just telling you. Come on, you get that?
No, just visual.
No one's asking you anything. The only thing I wanted you to add here was this. If lines are perpendicular, they form right angles. And if they're right angles, they are what? They are congruent. That's it. I agree with you. That's what my whole lesson was just a minute ago. I feel like you should just be able to say, if they're perpendicular, the angles are congruent.
Yeah.
But you're not allowed to do that. You say they're perpendicular. Perpendicular just means they form right angles.
Yeah.
In the definition of perpendicular, it doesn't say they form 4 right angles and those 4 right angles are congruent.
Okay, so you have to go ahead and say it.
The next step, that's all I'm trying to say to you. All right? And if you don't know that, write that down right now. That's your job. I don't want to write it down. All right? If you don't think you can remember that, you write that down. I'm giving you permission to do that. All right? Now let's look at question number 2. All right? Write a 2-column proof. We're trying to prove that those triangles are congruent. Oh, let me go back real quick. All right? So the triangles are congruent by what? No. By side, angle, side.
Is it like a postulate or anything? We should say
Side, angle, side. Right? Yes.
What is the postulator theorem that, I just don't remember the name, that says that right angles are congruent? Is there a name for it, or do you just write that?
I just write all right angles are congruent.
If you forget,
That's what I'm saying. I don't-
Say that.
Right, I don't, that's why I'm kind of trying to tell you guys, I don't have all of them memorized. I don't want to know the names. Part of the reason why I don't want to know the names is because I look at 5 geometry books and they all have different names. Right, it's whatever the author thinks is correct. All right. But if you say all right angles are congruent, no one can argue with you because that's a fact. All right. Again, if you're unsure, this side angle side is a what? Right. It's a postulate. That's a good observation. Down here, it said side, 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 what? Postulate. I find it hard to believe. So all of this is based off what? Observation. There's no way to prove that's true. All right?
So you would just say that like LPM, you first have to say LPM is right angle because they're perpendicular, and then you have to say LPM equals 90, and then you have to say
No, you didn't write. You didn't hear me. Not at all. Nope. You ready?
yeah,
When you have perpendicular lines, they form what?
4 right angles,
They form 4 right angles. If they're right angles, then they are what?
90 degrees.
They are congruent. You don't even have to say they're 90
You
degrees.
just have to say that they're congruent.
You need to write that down. All right? Then you get a good visual. All right. All right. So here we go. Let's try to knock out number 2. All right, here we go. Write a 2-column proof. Given AB is equal to CD. So you mark it, and the figure's already marked. Do you agree? Yeah. Then it says AB is parallel to CD. So that's all what? Marked
Oh, wait,
for.
no, you just do a parallel, so this works out.
Say that again?
They're parallel, so it works out. So we can do like an angle.
Yes. Brilliant. All right. That's how big it was. So there's our statement, there's our reasons. All right, and this, of course, is the given. All right. So, what's step number 2? I'm listening.
Angle CAB is CDB.
CA what?
CAB is CDB.
No, let me explain why. Because that would be if these are parallel.
Oh, I know.
You hear what I'm saying?
Oh,
Oh, no, ABD.
All right, tell us what. Go ahead.
I was going to say BDA and CAD.
That's what he said. BDA, yes. What?
So DAB is congruent to ADC because they're alternate interior.
There you go. Those are congruent, guys.
I thought that's not what it said.
wait.
No, you
That's what I
said
meant to say.
Well, you said, like he did, these two angles. No.
Why are they not?
Why not?
I'll demonstrate, because obviously I didn't do a very good job last chapter. Here we go. Let me explain why now. All right. Look, here's the easiest way to figure this out. What angles are congruent? All right. This is parallel to this, right? This is the transversal. Everybody see now? So therefore, these angles are congruent.
Oh, these are the
Yeah.
transversal for the other.
That's what I was trying to say. What?
And all the other ones we did, like the bisector line.
I don't see anything about bisector line here.
AD.
It doesn't say that.
Where does it say AD bisects anything?
Well, it's like the same line in EL in the last one, right?
Honestly, listen to me. I don't care about the last one. I only listen, and I'm really not trying to be funny. I'm just trying to say you're only allowed to look at this information. If they don't say it bisects, we don't know if it does or doesn't. You with me? And I'm telling you, when they say parallel, you look at corresponding or alternate interior. That's always the way it is. Always. All right? That's always going to be part of it. All right? Because that gives you two congruent angles. So again, we're going to say angle BAD is congruent to angle CDA. And that would be alternate interior angles. Alternate interior angles are congruent. And you can write alternate interior angle theorem if you like. All right? So now I have a side. I have an angle, which means I need another
Side. So you can say AD equals AD by reflexive property.
AD is congruent to AD. We would say reflexive. And then because we are lazy, step number 4. And then we're going to say what is the reason?
That's there.
Side angle side. That's how simple. It's very easy. Very, very easy. Yes, some of you are familiar with that. All right, now, if you're looking at this right here, all right, if you're looking at this right here, I'm not real happy with this figure right here because I'm not sure if they're trying to be deceptive or not. All right, that's what I'm thinking, right? And also, it doesn't look like YVZ
Yeah,
is
very-
linear. Is everybody with me?
Yeah.
And you could check if you drew it out,
Line, yeah.
right? Okay, but what, Ryan? Quickly.
CAB is the square.
What?
What?
CAB is that supposed right angle at the top. CAB is on the triangle.
You didn't.
Oh, okay.
Yeah, that is
So
true.
look. Yeah, look right here. That's a good point. Thank you. I think they're trying ACD, and it would be.
ABD.
Yeah, they made another mistake here, guys. I should look over that more closely. Shh. So look, ACD would be congruent to triangle D, right? So let's rewrite this one. Look right here, guys. Everybody fix this now, please. Thank you. This right here. All right. Now, this corresponds to D. Do you agree with that?
Mhm.
So that would be D, and then B, and then what? A. Is that right? A, C, D, D, B, A. Oh, I forgot. Oh, there you go. Hey, did you see the mistake they made?
Yeah.
All right. You good with that? Yeah, they all right. Thanks again. All right. All right, now let's look back here. All right. if V is the midpoint, and again, because we're running probably short on time here, if V is the midpoint of YZ, then what's true? Yes, YV would be congruent to VZ by definition of what? Midpoint. Then it says that V is the midpoint of WX, so, and that's definition of what? Midpoint again. All right, now you can see I'm not really sure what they're trying to do here. You would simply say that angle what? And they are vertical angles. Vertical angles are congruent, and then the triangles are congruent by what? Side angle side. They're vertical angles,
How are they?
right?
Oh, yeah.
What?
It doesn't look like.
No, I listen. The only thing, that's what I'm trying to say. I'm trying to see if they've actually made a mistake. Since they've made a couple mistakes, I can probably assume this is a mistake also. But it's not linear. So what they would have to do is they would fix this, or they would have to fix it so it looks something like that. Then it would be better, right? But if something's the midpoint, that automatically means what's true, that all three of those points are on the same line. If something's the midpoint, that means all three are on the line, right? So I'm trying to see if maybe they're trying to say if you're paying attention or not. I don't believe that probably. I think they just made a mistake when they drew this out. Right? But if something is a midpoint, then all 3 points are on the same line. What?
So you're saying that V is.
I didn't say that at all. I didn't say that at all. It says V is the midpoint.
Yeah.
What they did when they drew this figure out is they probably did this, zip, and then accidentally did this rather than drawing a straight line. I don't think they're smart enough to say, wow, I'm going to see if these kids are really paying attention. Right? It's just the fact that if it's the midpoint, they're all on a line. So we're looking at this going, that's obviously not a line. So it can't be a midpoint if it's not a line. So somewhere, you see what I'm saying now, right?
Yeah, it's two separate.
Yes. All right. So now, Isabel going to ring? Okay, so here is what I want you to try to do now. I want you to try 4, 5, 6, and 7. These are the main problems right here. Now, with question number 4, it's kind of annoying because you have to do what?
Graph it.
Yes. Now, when you plot the points, all right, to show that the lines are congruent, you simply have to use the distance formula. All right? Now, if they make vertical lines, which they very well might be able to, you could use vertical angles. All right? But we still have like 4 minutes.
We have 3 minutes.
3 minutes. Okay, so let me go ahead and I will plot the points. All right, now I also learned this technique for some of you guys who care. And when you copy that and you put it down to your graph paper, you don't have to keep scrolling up. So everybody see that?
Yes.
All right. So now let's plot those. -3, 3. -1, 3. And -3, 1. And then 1, 4. 3, 4. And 1, 6. So those are congruent by I would say side angle side. Right? This is a right angle. They're perpendicular. Alright? Then we can say this length right here is 2. This length is 2, 2. So the triangles are congruent by what? Side angle side. Alright, that's not that hard. Alright, draw the figures out. Alright, I like what we're doing here as far as if you copy things properly. Alright.